Good. Okay, that's one of, I think, a very interesting piece of design wisdom, really. Open close principle probably bears a little bit of reflection. And we put it in the context of a variety of forces that are influencing the shape of the designs we start to assemble. So it's not the primary principle, it's one of a family of principles that often we're trying to hold in balance. Right, our next topic is to now move away from these principles and look at some practical matters associated with the project we're asking you to build. You'll see in the upper edges of the assignment grading spectrum, we're looking you to expose the pacemaker service as an API and to perhaps develop a client for that API, and then ultimately in the outstanding grade, put that API into the cloud. And we'll be developing labs to take our skeleton application through these steps. So you'll have the foundation for the additional commands and features and data structures we're asking you to experiment with. So next few minutes, we're going to talk about HTTP in general, because REST is a HTTP protocol. Some of the considerations of building an API, if you haven't been building APIs in the past, and then what we mean by REST. And finally, I'll go in detail through what you'll be doing in the lab today with an explanation that's also covered in the lab itself. First of all, we'll just remind ourselves about HTTP itself, something we use daily. We're using it right now. Everything we use on the internet through a web browser is using the HTTP protocol. And the HTTP protocol is at the heart of APIs in the modern era. We're probably familiar with a variety of protocols that are already there. Email protocols, SMTP, POP, file transfer, FTP, and the like, SSH. The web, we often talk about two standards and protocols, HTTP and HTML. All these protocols operate in the OSI model. It's a theoretical framework for understanding how networks work. It's not a level of detail that concerns us substantially, but we just need to be a little bit aware that we're dealing with a network when we're exposing an API. And in particular, we're dealing with a layered network. This is a well-known way of visualizing how these layered networks work. At the highest level, a manager wishes to send a message. He or she dictates the message, an assistant corrects it, secretary packs it, a driver delivers it to a post office. It's sorted, unpacked, transmitted from one region to another, unloaded, unpacked, sent back to another organization, retrieved, and then brought back to somebody to ultimately read it. The key point about this type of analogy is that each layer depends on the layer below and offers services to the layer above. And that's been the key to how protocols on the internet have been designed since their inception. We don't use a 7-layer model anymore. We use a 4-layer model: network interface, internet transport, and application. And they correspond to those lower level OSI model layers that I just mentioned. In fact, all the protocols I mentioned are all in the application layer, including HTTP. So we're up quite high on the stack, sitting above lower level protocols, particularly TCP, IP, and of course, internet itself. Let's look a little more detail at HTTP. What happens when you click on a page on internet? Page is rendered in the browser. Your browser connects to a web server, and if it wants to do that, it's usually connecting initially to a DNS, so you can get the IP address of the server. And once you have the IP address, the protocols collaborate in a quite sensible manner. Sync to see is the server there, sync acknowledge, then another acknowledge of that acknowledge. Then a GET request is made, respond with 200 and the message itself, maybe another GET request, and more content. then a finish message sent from the client to the server. I'm showing you interleaved here one upper and one lower layer. We're looking at HTTP messages and also TCP messages. Could go even further down. We could look at IP and maybe Ethernet, but we're not. We're just looking at the upper layers here for a few moments. In fact, we're working with HTTP, we ignore all the lower layers and we just talk about a request and a response. We think of a single request being made and a single response being delivered. And in the context of the modern web, the request delivers us a page and the client, the browser, renders a complete page. It retrieves in the response. As you probably know, it's a bit more complicated than that these days with Ajax and HTML5. Bits of pages are being sent down all the time now rather than complete refreshed single pages. But the substantial analogy holds. You're familiar with URLs, protocol, domain, folder, paths, and ultimately down to pages. And this naming scheme has become ingrained really in how we think about navigating the web. If you've built static websites, you're probably thinking these are folders and subfolders and ultimately files inside a file system, which they may be for certain categories of site. But of course, that's entirely up to the server. And the server may be holding the illusion of these folders merely to give a URL some meaning and navigability. HTTP itself has got a variety of components. I'm going to skip through them here reasonably quickly. It's not important we understand all this detail, just that we're aware of some of the major features, because when we're debugging REST APIs, aspects of these do become apparent. And at the very highest level, we do need to know what request methods are and response codes are. Lower level headers, entities here are less important, but we'll touch with them very briefly in the next few minutes. So request methods: get, post, put, delete. These are primary verbs, we call them, or methods, that the browser uses when interacting with a web server. Get a page, that's what you're doing when you navigate typically. Post a request, this is what you're doing when you're submitting a form. Put and delete are less obviously used in the context of a standard user interaction, but the browsers are aware of them, and particularly the servers and any caching layers between the client and the server are aware of them, and they're an important part of the HTTP standard. We talk about safe methods and unsafe methods, that is, ones that have side effects and ones that have no side effects. For our little experiments, we can restrict our attention to get, which is the primary driver for retrieving resources, post for updating, and delete. We'll be using all three of these in this week's lab and next week's lab. The others are less important for us, and many of them are not used in APIs development generally. The response codes are also something we need to be aware of. They come back as 1 and 2 digits, the 3-digit response codes: informational, success, redirect, error, or server error. So we're often interested in success and maybe communicating an error to the client. And the numbers here are significant. We'll see some of that as we go along as well today. The other ones are less important. Request headers and response headers. These are additional textual information carried in a request and by the response. In the context of your day-to-day usage, they're often only really of use to the browsers themselves for assessing the quality of the responses they're getting back, and they're rarely exposed to the user. We won't either be digging into these when we're developing our REST APIs, but some of the tools we will be using will reveal them, and were we to go on and cover authentication, for instance, they would become of significant interest. General headers to do with caches, date times, etc. on the client and server. Entity headers, particularly what kind of content we're sending back. We're going to be text mostly in JSON format. Obviously, streaming content and multi-part content is also part of this standard. Content itself then, audio, image, video, and 9 general media types you might have heard of. Again, not that relevant to what we're doing today. Now, the stateless protocol, as you might be aware of. So each request is independent of the requests that come before and after it. It's a design feature of the web, and it's a design feature of REST. Other API standards incorporate session management of various kinds. The REST API does not. Now, there are mechanisms for introducing session-like behavior, including tokens, but they're to the side of what we're discussing in these labs. Quick example, get. This is what you might be looking at if you were to look closely what a browser is doing when we issue a simple GET request to a server. The HTTP request has got these GET verb, it's got the host specified, and then various of the headers I've just name checked start to come in here. The kind of content we can accept, what language we're working in, and so on and so forth. Here is the request line we just looked at. And there you can see the various other headers informing in this case, the server of the capacities of the client. If we want to send some information like parameters, if we're submitting a form, for instance, then if we take a look at how that might look, our GET could have additional information present in the request URL. That is, you may see this when you're browsing the web occasionally. The address bar seems to contain quite a convoluted and extended address. And what's happening here in this example is we're adding on extra information, like a Mr., nobody, and OK values submitted as part of the GET request. More typically, that type of information would be submitted as part of POST, not GET, and then the extra information in this instance would be delivered as a body of the message here. Now, all of that is quite low-level detail for us. It's probably something you've covered many times in your own computer science education in the past. It is the protocol that drives the internet. It's been deployed across the planet for 20 years now. And because it's so widely deployed, it is regarded as the ideal vehicle for machine-to-machine communication. That is for building APIs and writing programs that consume those APIs. To date, it has been obviously used in its intended form for rendering web pages, but also repurposed same protocol to use in the context of the APIs we're now discussing. That's general context. I'd like to keep going for a moment, and we'll take a break, maybe another 10 minutes or so, by talking a little bit about APIs at a fairly high level, and then we'll take a stop for any questions. Bearing in mind the context we've just been through, let's talk a little bit about data interchange formats, compare the web with APIs in general, and then take a preview of some of the tools you will be using in the labs as we start to explore APIs in the context of our skeleton application. First of all, data interchange formats. Again, as a programmer, you've encountered many of these formats. CSV is the original of the species, I guess, simplest way of representing information in textual format. Still widely used as Excel, for instance, can import and manipulate CSV files automatically. Name value pairs, probably more programmery. If you've looked at any configuration files for any tools, particularly IDEs and the like, Eclipse, for instance, has loads of these files hanging around in your Eclipse folder. If you have a peek into them, you'll see them. YAML is a programmer's favorite as well. It's a little bit more structured than name value pairs. And you could think of it as a way of storing data structures. It has been used for that. You've already experimented with this in your assignment 1, and many of you got YAML translation working, in fact. XML, again, obviously influenced by HTML. They're both influenced by an older standard, HTML. Here we're using open tag, close tag, so the information is quite structured. And the last one, JSON. Quite similar to XML in some senses. It's name values, but they're packaged in a notation that's aligned with JavaScript. It's not JavaScript exactly. You can't include code in here. It's pure data, but it's name value pairs separated by semicolons, delimited by commas, and encapsulated in braces. The names and the values are always quoted, except if they are numbers. JSON is the format that is preferred in REST, and it's the one we'll be using. However, parsing JSON into Java and vice versa is something we'll be relying on our tools to support. Briefly again, remember, it's all on the web. It's all HTTP. These two screenshots here are showing you the same page, but one is revealed through a standard web request. It's a standard URL. It's a GitHub page for this course, in fact. But that content is also available through a different URL. It's available through an API request. And you can see, it's hard to see in this resolution, it's JSON format returned as opposed to HTML for the top. So when we, in a browser, go to a website, we're issuing a GET request, we're getting a HTML page back, maybe a style sheet, and it's rendering as expected. The browser can also request an API. If you take this link here and put it into your browser, you'll see exactly what I'm seeing. This is obviously not intended for a human reader. It's information intended for a program. It's a result of an API call. And you can reveal this details in Chrome if you like. Turn on your developer tools, instructions in the lab on this. Have a look at the network tab and you can see the information nicely presented usually in, and searchable inside the network console. Programmers working with APIs often use a command line tool called curl. We won't be using this, but I'm just name checking it on the way here. Curl is like a way of issuing GET requests from a terminal, from a command prompt. And it has a range of other features as well. But if I were to issue a curl on the API we just looked at, I'd be listing the results out on the console. Obviously, this type of tool here lends itself to developer support as we're growing or experimenting or maybe consuming existing APIs and getting to grips with the basic mechanics of them for debugging purposes, for instance. And in that context, in the lab today, you'll introduce a Chrome extension called RESTlet Client. And you'll be using this to explore the API that you are going to build. It shows us much the same thing as was visible in the console, except it's easier to understand. Supports JSON directly, so we can enter JSON values for post requests. And in general, we can keep an eye on the API we're building and start to reason with some of the responses we're getting back. These tools do, of course, all reveal details of the HTTP protocol and the headers I was briefly discussing. So all of that information is here. Again, it's not that interesting to us, but we are very interested in seeing the response body, or payloads as we call them, which will in fact be the data structures we are starting to expose via our API. So that's a general intro to the context. Protocol itself, you're probably familiar with it. Nature APIs, particularly JSON, and the fact that JSON really is the lingua franca, really through which we communicate with APIs globally. Okay, we'll take a short break now, and when we come back, we'll dig into how the hell do we build an API, particularly what REST means. We haven't introduced that quite yet. And then particularly what you'll do today to get REST enabled on the skeleton app we built last week. Okay, talk to me in a few seconds then.